In the digital transformation of the power industry, we see an increase of use of digital twins. A digital twin is a digital copy of a physical asset and have proven to give many benefits.
In this presentation, we are going to show you how to use the digital twins for relay protection testing. It's very important to mention that the twins can share the same data. And we can share the same screen. And also we can do the same things that you do.
Indeed we can. Let me introduce Niclas Wetterstrand, Business Development Director for Megger.
And here, Andrea Bonnetti, Senior Relay Specialist in Megger. And now you guys, you have to leave the scene. Thank you very much.
So while our digital twins work on the commissioning test, I want to make an introduction of the subject, the latest advances in digital twin solutions for virtual relay protection testing. But before we go into the real presentation, there are three things that I want to highlight. First thing is that Megger and IPS have reached an agreement to become strategic partners. IPS is one of the leading providers of enterprise asset management, asset performance management, outage management, and mobile software solutions and more for the electrical supply industry. Gartner ranked IPS as the world's highest performing niche player for the execution of the enterprise asset management. So two strong companies coming together and make things that will be very interesting to follow. The second thing is that I want to shortly, briefly introduce Megger. As most of you hopefully know, we are a test and measurement company and the leader in the industry. We have test solutions for any part of the electrical network. We are a global company of 1,450 employees. We have 8 manufacturing sites based in Europe and in US. We are proud of the people culture and the strong values we live and work for. And we reach 163 countries through sales and distribution offices worldwide. And talking more about that part, we say that we are a global company, which is a combination of being global and active on all continents with our 40 sales offices and 100 distributors. We act global to be local, close to our customers. So that's why we use the word global. This is a substation just next to the Megger Sweden office. The third thing I wanted to mention is to highlight the Electrical Tester magazine, which is a free magazine from Megger with very high valuable content. It's normally around 20 articles, technical articles with focus in test and measurements for the power industry. So please, if you didn't do it already, go to the Megger website and download or read it online. But now we go into the topic. What once started into video games with virtual reality a long time ago have reached the industry where we create virtual environments to get great efficiency improvements like cost savings and time savings. In the digital transformation we see in the power industry, we also see benefits like in system design where you get an accurate fit with no changes when coming to reality. In training purposes where you can work several in parallel and you don't have any hazardous voltages, etc. in development, when you again can work in parallel and you can test parallel systems. Not the least, we can say the last year with the pandemic situation and all challenges that have been with that, with social distancing and remote work. All these is possible and enabled by working in a digital environment. We see an increase of speed of this digital trend, if you put it that way. It's accelerating and it meets needs and the benefits that many customers request. And if you look into a substation environment, the digital substation creates an acceptance for tools like virtual relay testing. And there is an increased investment in this area as well over the last years. We see early adapter proofs through LinkedIn and ResearchGate, where people and companies have acquired this technology and get benefits in training or factory acceptance, for instance. So what I would like you to do is to join Megger into this trip into the future by this presentation. So with that short introduction to set the scene, I hand over to my colleague, Mr. Andrea Bonnetti.
Good afternoon. Thank you, Niclas, for your introduction, and thank you for all of you for listening. My name is Andrea Bonnetti, and I will guide you now to the rest of the presentation. So, are we talking about digital twins? Are we talking about simulation? When we talk about simulation in IEC 61850 world, two concepts come in our mind. The first one is the IEC 61850 simulation bit or simulation mechanism, very much related to the fact that we have some mechanism in the standard that allow us to superimpose simulated goose message, simulated sample values message to the real messages that are traveling through the network and allowing us some test methods to simplify the life to the test engineer. But this is not it's a very important concept, but it's not what we want to talk about today. The second concept related to simulation, and here I have received many questions that people say, this is nothing new, we can already simulate relays. It's related to 61850 SCL data model, simulation of the SCL data model, where we have software tools like SICAM protocol test system or hardware tools like our relay test sets, that can import the SCL file containing the model of the device or the devices and simulate it because the model is understood, and I can raise a signal into this data model, the general trip signal, and in the model that is written, when this signal goes up, send a goose message. So the Siemens protocol test system will send a goose message, or my test set will send a goose message. But this goose message related to the trip, for example, of the signal, is not related to any injection of any power system fault. So it's not really this I want to talk about. We want to talk about the application. So how fast is this trip generated from when the power system fault was applied? Or I really cannot send the message. I cannot raise the general trip at all, but the SCL file allows to raise it when I simulate the SCL file, because the general trip, the protection function is blocked. It's blocked by binary input. So it cannot trip if it is blocked, but I can, when I simulate the SCL model, I can really simulate the trip without considering the application. So I want to consider the application. And I want to test the application. So how can we test the application? And considering also that an application is not standardized, it's still left to the competence of the manufacturers, both of relay protection and relay test sets. So if you want to test the application, take the protection relay and run the test. There's nothing new. We have always done like that, and we still do like that. But I would like to have a virtual representation that serves as a real-time digital counterpart of a physical object or of a physical objects. And yes, these are the digital twins. The digital twins, they exist. The digital twins exist for relay protection, C-Protect digital twin, SAR-Protect digital twin, and for relay test set in Megger, digital twin for our FREJA and SMRT series. What can we do with them? When we have digital twins interacting, first we have to have them, but then we have to make them interacting. We can talk about virtual relay testing. And the benefits for virtual relay testing are actually, for example, that several people can work in parallel fully independently. One engineer may test a setting group 1, one engineer setting group 2, 3, and 4. Easy to get remote support from experts or colleagues because you are at home in the same time zone, so you can easily get answers, some help from your colleagues in case of troubles. It's a more comfortable environment, and this makes that you will have less pressure on site, and because you can do the work anywhere at any time. You can also do the work on site in the hotel when you come back during the weekends, for example. Verify some things. Geographical barriers can be eliminated because think about the line differential protection, where we have two relays at both sides of the line, and then we can put them on the same virtual environment and test perform many tests that are not based on the perfect simulation of the communication line between them. And also we can do tests that we couldn't do before because they are too complex to physically manage. We can generate a virtual relay test set with 50 current generators, and test and connect virtually these generators to the relay and run a substation test that we wouldn't do in the reality only because of the complexity. Considering now the number of the virtual tests, which is the number of tests I perform in the virtual world, when I am in commissioning on site, I can take a restricted number, then subset of them, and perform them on site just to verify that the system is still working as it was working before. So the number of the test of sites is definitely reduced. And on site, like always, not only in this case, we may need to perform some new tests because we have a new connection to verify, we have a functionality of the input outputs, etc. So there are some tests that definitely I have to perform on site, and these tests are new. But consider, please, that before and still now, all these tests usually were done at site and starting from scratch. So you arrive there, maybe the relay is not configured at all, depends on the situations, and you have to perform this test with a question mark that you use from the beginning, don't know if you have to change the relay settings, etc. Now instead, you know that things should work. The second important, maybe this is the first important, seeing the feedback we receive, is in training. Use of digital twins in training. First of all, it's safe. You can inject 60 ampere, we don't burn test set, you don't burn the protection relay. You can touch the 300 volts because they are not there at all. Deja vu, the situation that you can say, I've seen this already, I know it should work like that, why it doesn't work now? And in training, instead, you when you can divide the training into virtual training and real training and physical training. So you can, when you work on the real test set, on the real relay, you have already seen how the tools perform, how the test set performs, how the relay performs. So you are in a much better position to better understand other things that happen in the reality. And of course, there's something also very important. You can give to every participant to the training one test set, its own test set, and its own relay, so that they can think by themselves. They don't need to interact and be divided in groups. Then at the end of the training, when you perform the real training on the real devices, you have to group them, of course, and it's also good because they can exchange and discuss together, which is one of the most important things you can do in trainings, letting people work together. But they can start to think by themselves, and this is very good, and it's something we are lacking today. Reuse of the information. Something I'm going to talk several times about that. You can use the relay files that you have validated in the virtual tests can be reused in the substation. And the test set files that you have validated during the virtual test also can be reused in the substation. And also you can use the knowledge. As I said, at commissioning, you already know that things should work. And this is a very powerful position that say, okay, it's not working now, but it was working before, and you can pinpoint probably few roads, few ways to investigate why there are some differences. The digital twin for FREJA is working like that. We have our RTMS software that normally connects through Ethernet to a real test device. Now we have had the possibility to connect the RTMS software to a digital twin device. And when you select the digital twin, you can choose the following devices, which are the most important test devices we have, and the list will grow in the future. Or the RTMS software virtually talks to the digital twin. The test engineer can prepare the test files in the same way he has always done. Prepare the files, prepare your list, and run one after each other, or select one. In this case, we just select one, 3 pins on one. We select the test file and we run the test in the usual way. So we press the button. The question is, of course, what happens? Because where are the currents? Where are the voltages? Where are the electrons? And we have to understand that the test is run according to interfaces that have been decided between the digital twin test set and the digital twin relay. Today, at the moment, this interface is ComTrade. So when the digital twin runs, it saves the result of the test in a ComTrade file. Voltage and currents are in ComTrade file. And then we have done some user-friendly. You can verify the ComTrade file in case you have done the wrong sequence, you have done some wrong values, etc. Or you just save it in ComTrade. But you are not saving as ComTrade. You are running the test, digital twin runs, and the output is ComTrade. So the test file is saved in the normal way. It's a PowerDB XML file. So this file that generated then later on the ComTrade, but it's not important now. This file can be used with the real test set. So when you open this file, just make sure you connect to a real test set. Simple. So now, when we are connected to the real FREJA test set and we have our test file, we are in the real world reusing the test files that have been generated in the virtual world. This is what I mean when I say we can reuse the same data. So one test file, again, I have to explain this again, I think. When one test file is opened by the digital twin, the output generators of the digital twin are a ComTrade file. And when the same test file is opened by the real twin, the output generators are the usual voltage and current generators that we are comfortable with. for the protection relay, we have CyberProtect Digital Twin, which is the real-time digital replica of a physical CyberProtect file device. So the files that have been generated by the testing device are uploaded into the CyberProtect Digital Twin environment. Upload ComTrade. When we have the ComTrade files, for each file we map the signals of the test set, which are signals in the ComTrade file, voltage A, B, and C. We connect them to the analog input of the relay, voltage analog input 1, voltage analog input 2, voltage analog input 3. Also, we connect the current generators of the test set, which are ComTrade files A, B, and C, into the ComTrade signals in A, B, and C, into the current transformer signal 1 and 2 and 3 of the relay. So we are connecting virtually the test set to the relay. And then we tell the environment to run this information into the relay, so play. And what happens here is a test result. The relay runs algorithms, settings, etc., and the result is there. So the result is available at the virtual HMI for the first analysis. Many times it's important. No trip, you see nothing happens. Trip, you see the letter appearing. You can verify the fault distance. You can go up and down with the buttons here and see which zone says trip, event recorder, etc. In second analysis, it's possible to access the results by looking into the disturbance recorder or event recorder generated by the protection relay after the injection of the fault or the test injection. In this case, you can see that we can measure then. This ComTrade file is coming from the relay, and the fault started here. Voltage goes down, black current goes up, fault starts here. After this time, we have a general start, and the trip here is here, and we have the trip after 30 milliseconds. And so this is very often tests are done this way. So if errors in the configuration, setting, or specification are found, then can be corrected from the IEC file. The file can be transferred into the digital twin, and the test can be repeated. When the results of the test is okay, the same IEC file can be used for the physical ID. I load the result into the physical device. So the Megger twin and the Siemens twins have actually access to the same data. RTMS software takes a test file, can run it against a twin, or can run it against a real test set. IEC can take a IEC file and can run it against a relay twin or relay or physical relay. This is very important for a easy virtual commissioning and having benefit of the results into the real world. Simple test. Which kind of test we can do? Very simple tests that can be done from the HMI directly. Front display functionality, verify that the HMI is working, that the single line diagram you have to show the correct data. Some logic, some simple interlocking logic, some 6150 signals, inject a fault, and verify that the goose message is sent. There are tools on the virtual environment to verify also the goose messages are sent. Where we need to investigate the internal disturbance record of the protection relay for verifying more complex tests, like the switch on to fault logic can be quite a tricky logic dedicated with the deadline detection or not. Some settings can be tricky as well. This is not one shot. These are 3 or 4 or 5 tests you have to do these things. Intertripping schemes, overreaching, underreaching, are really coming in the correct way? Is the acceleration logic working correct, etc. All the settings group needs to be tested as well. So this is a certain complexity, maybe not very difficult, but tricky. Correct cycle number for the logic gates or the correct compilation speed of the logic is used. This you need a disturbance recorder because you want to verify that you have not introducing unwanted time delays into the instantaneous trip logics. And also, by the way, you can do many tests that are not reported, and these tests you do only because you want to verify that you are thinking right, or that you have been thinking right. So, when we talk about new technology, new ideas, it's always very important to verify what the standardization does. Is standardization following this logic, this concept or not? Because if the standardization is showing interest into this concept, then we are more keen to follow it and to take it into consideration. And actually, the IEC standardization is looking very much on digital twin in general, digital twin technology in general. We look at working group 6, which is dedicated for digital twin. We can see that there are many preliminary work items. Documents, we are expecting documents with the reference architecture, with the use cases, with the definition of digital twin. And it's very important now that we, in our substation environment, a relay protection environment, participate, some of us, into this group and bring our needs also, so that our use cases are also standardized or taken in consideration by the standardization. We have also written a paper recently for IEEE, and you can find it on IEEE journal, but if you are interested in this paper, please let us know and visit us at the booth. We can discuss about this. So I'm done. I say thank you very much. My mail address is below here, so you can find me by mail, or easier probably on LinkedIn. If you want to have more information about the Siemens digital twin world, please contact Cédric Arispuru, who is the product manager for this project into Siemens. And I have explained the most simple things about Siemens digital twin. More details, information, please contact directly Siemens. And now the question is, how are our twins doing? You remember, we let our twins test in the relay in their virtual world. Let's have a look how they are doing now.
Hey guys, are you ready?
Can you give us the relay setting files and the test plan data, please?
Thank you so much for watching. I hope you found this video insightful and enjoyable. We post new smart grid related videos every Friday at 12 CET, so please go ahead and subscribe and let colleagues in other departments and peers in other organisations know so that they can benefit too. We welcome your feedback, so if you have any comments or questions, please feel free to post them below. Thanks again and have a great day.